Hello and welcome to Homework Helper for 2.5. We're going to have a little bit of a break with the PSATs, so you should have plenty of time to catch up on 2.4, 2.5, and even look ahead to 2.6 if you need to. We're going to start with this ready section where we're going to be writing equations of lines. And so before we even get there, let's make sure we know what we're talking about. It tells us that we have slope-intercept form right here of y equals mx plus b, but let's just make sure we know what's going on here. So when we have y equals mx plus b, the y and the x are always going to be in that equation. The only thing that's going to change is going to be the m, which is our slope, and the b, which is our y-intercept. Now the y-intercept is just where it crosses the y-axis. So right here, that would be our b. But our slope is going to be our rise over run. It'll be represented as a fraction, which is our change in y over our change in x. So when we look at this, it's actually pretty kind. I'm going to do number 2 here, where it just tells us what our m and what our b is. So when we know what our m and what our b is, all we have to do is plug it in here. So I know that y equals mx plus b. I know my m is 3/8, so instead of writing m, I write 3/8. And I know that my b is minus 3, so instead of b, I write negative 3, and I'm done. Now that's pretty easy. That's just, making cup noodle soup. Add water, heat. But for the next one, we've got a couple more difficult things we need to do. It gives us a different form. It's called point-slope form. Now this is different than the slope-intercept form that we've used before. In point-slope form, what we have is y equals mx minus x1 plus y1, where x1 and y1 are a point x comma y. So what we need for this is, instead of needing the y-intercept, if we have the slope and a point, that's why it's called point-slope form. We're not very creative. We can now construct an equation. So when we do this, let's look at number 4 here. We are given a point and a slope, and so from that, using the point and the slope from point-slope form, we can solve this. So we have y equals m times x minus x1 plus y1. So let's go ahead and give this a try. Y equals, well, instead of m, I'll write what my m is, which is 9. X stays the same, but x1 is the x of my point. And what's the x of my point? 0. So minus 0. And then I'm going to add the y value, which is negative 7. So now I can simplify this, right? Because x minus 0 is just x. So y equals 9x minus 7. And I'm done. And actually, once we get here, we can see that this is just slope-intercept form, right? Because we had x equals 0, which is going to be our y-intercept. That means our corresponding y is the y-intercept. But let's do another one. I'll jump over to 6. So let's try this again. Y equals mx minus x1 plus y1. Okay? And so now I'm going to do the same thing. Y equals, instead of m, I'm going to put in negative 5. X minus whatever my x value is, which is 4, plus my y value, which is 11, plus 11. And there we go. I'm done. And so it doesn't ask you to do this, but this is just a little bit of an extra. Let's say we have this equation and it asks, rewrite in slope-intercept form. And rewrite in slope-intercept form. You might be thinking to yourself, okay, how do I do that? Well, let's start right here by distributing. Let's do a different pen color. Let's start by distributing this negative 5 into this parentheses. So I get y equals negative 5 times x, and then negative 5 times negative 4, that's going to be plus 20 plus 11. Combine my like terms, so negative 5x plus 31. And so now here it is in slope-intercept form. And so one of the things that may not be obvious at first is that though this is point-slope form and this is slope-intercept form, these are both talking about the exact same relationship, and in fact would be the exact same line if we were to graph them out. Just something to think about, but again, this is where you need to be. This is just kind of stretching your knowledge a little bit for further down the road. Let's turn the page. For the set, it's going to give us some information and we're going to be able to write an equation and graph it. So let's see what it tells us. It says the beginning value is 5. Well, that tells me my n sub 0 is 5. But that also means my b is 5. And then the value is 3 units smaller at each stage. Okay, so that tells me that my common difference is minus 3, but that also means that my slope is minus 3. So I know that my equation is going to be y equals negative 3x plus 5. And then it asks me to graph it. So I'm just going to draw some lines here. Draw them like this. Okay. And so I know that my y-intercept is 5. So 1, 2, 3, 4, 5. And I know that my slope is 3, or negative 3. So if it's negative 3, that's secretly negative 3 over 1. So my change in y is negative 3, and my change in x is 1, right? So I go down 3, 1, 2, 3, that's my change in y, and then I go over 1. Down 3, over 1, okay? And that becomes my line, just like that. Okay? So keep in mind, once I found my b, I went down 3, over 1, to show my slope. That's how I did that. All right, next section, final section. Let's turn the page. What do we have here? Prove that the two equations are equivalent by simplifying the equation on the right of the equal sign. The justification in the example is to help you understand the steps, but you don't have to do the justification. So pretty much what I'm trying to do is I'm trying to prove that this equals all of this nonsense. So what I'm trying to do is I'm trying to get this to look like x minus 5. So let's see what I need to do. So I'm going to look at this and let me see if I can combine like terms. Yeah, I have an x term and another one here. So let me go ahead and do that. 5 minus 10 is going to be negative 5x minus 7 plus 2 times 3x plus 1. Now I'm going to distribute here. Simplify that a little bit. So I have negative 5x minus 7 plus, this 2 times 3x is 6x. 2 times 1 is 2. And combine terms again. Negative 5 plus 6 is just a single x. Negative 7 plus 2 is going to be a negative 5. And sure enough, those are the same thing. I have shown that they are the same. So that's pretty much what we're doing. Remember, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, adding and subtracting, where my dear and Aunt Sally happen interchangeably. When we look at something like this, the multiplying in is important. We got to multiply into that parentheses before we can make anything happen. I'll do number 15 as well, just to kind of show you guys that. So we want this to equal that. So I'll actually start with taking this negative 10 and multiplying it, distributing it into the parentheses. So I have 24, negative 10 times 2 is negative 20x. Negative 10 times 8 is negative 80, plus 62, plus 7x. So now I see that I have a couple of x terms. I forgot to write my x on the 7x here. Let's do that. Boom. So I have my x terms. I have my constant terms, 24, negative 80, 62. So now I'm going to combine the pinks, I'm going to combine the yellows. So let's start by combining the yellows. 24 minus 80, oh god, 24 minus 80 is 56, and then I want to add 62 to that, so plus 62. So I end up with 6. And then I have a negative 20 plus 7, that's going to be negative 13x. And sure enough, boom, I did it. I made it happen. All right, guys. That's what you need to do. Make sure, identify what your stuck point is on these, because there's a lot of complicated things that are happening here. Is it the distribution? Is it combining like terms? Remember, we can't combine, our x's and our whole numbers. We can only combine our x's with other x's. So keep that in mind as you guys move through this, and come back on Thursday with some questions for me. Have a good one.